In this video, I'll be doing the maths question you see on the screen here from paper 2 of the 2024 Maths Leaving Cert exam. If you're looking for a different question from this paper, check out the playlist in the comments below. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But remember, you're not in a classroom here, we're on YouTube, so take advantage of that. Pause, rewind, watch a half speed or watch a 2x speed. If you do find these videos useful, or any of my videos, I would greatly appreciate a like or subscribe, but especially I'd appreciate you sharing it with a friend doing the Leaving Cert or doing it next year. Question 2 starts off with a game here, a probability question about a game. And they tell us, very important fact, they tell us the game is fair. Now that just means that whatever money you put in, I would expect to get that money out. In this case, €10 to play the game. So a fair game means you get €10 back. Casinos don't do fair games. For €10 goes in, they would only usually give you 9 point something back. Obviously one game doesn't matter, but this is if you play 1,000,000 games, it should average out. Okay, so that's the information they give you. They also give you 30% of the time you'll win nothing, 40% you'll win €2, 28% you'll win X minus €10, so we don't know. 2% you'll win X. Use all of this information to find out what X is. So really, like I said, the trick here was the word fair. Fair told you that you will win €10, that the expected value of this game is €10, because they also told you it costs €10. So they're telling you €10 is equal to the expected value. We write the expected value as 30% or 0.3 times 0 plus 0.4 times 2 plus 0.28 times x minus 10 plus 0.02 or 2% times x. All that equals 10. That's really what they told us here. Now let's clean this up by just getting all of our numbers on the left and all of our x's on the right. So numbers we would have, let's say we'd have 10, that's 0. We'd have minus 0.8. Here's another number here. Minus 2.8 will go over and become plus 2.8. All right, all the x's, we would have 0.28x and we would have 0.02x. Let's clean this up. This side would just become 0.3x, or you know what, let's change that to 3 over 10 because it'll make the next bit easier. Left hand side, do it in calculator, you don't have to do it in your head, but this takes away quite easy to 2. 10 plus 2 is 12. Let's see, multiply both sides by 10, divide by 3, we're left with 40 equals x. And that's the answer there. They sometimes then would ask you to, other questions, they might ask you like how much was this particular winning or things like that. They might ask you questions about how would a casino change the game to make sure they win money. So if X was less, if it was even 39, over the long term they would win money. If it was 41, over the long term a player would win money. Part B is a much more theoretical question. There's no storyline here. We have two events, A and B. They tell us the probability of A happening is 0.1 and they tell us the probability of B happening is 0.4. And they want us to find the probability of A intersection B. This is A and B happening. And then they want us to find the probability of A union B, or A or B happening. One or the other happening. Now there's not enough information here until we add in the first line. They said A and B are mutually exclusive events. Now that means if one happens, the other can't happen. If B happens, A can't happen. If A happens, B can't happen. Now that should hopefully answer this one. What's the probability of them both happening? Well, mutually exclusive means they can't both happen. They're just, if one happens, the other cannot happen. So 0. I think I said the last thing correctly. Anyway, the probability of one or the other happening. Well, that's just them added together. That means, well, 10% chance that this happens, 40% chance that this happens. Well, that's a 50% chance that one of them happen. And then obviously there's a 50% chance neither of them happen, which they didn't ask about here. So that's it for part B. You just needed to know that mutually exclusive meant this was 0. Then you could draw this in a Venn diagram to help you think about it. So one of them was 0.1 and one of them was 0.4. Being mutually exclusive means we know this has to be 0. So this has to be 0.1 and 0.4, and the union of these is just these three numbers added together. So that becomes 0.5, and I guess to complete the Venn diagram, there'd be a 0.5 outside. They didn't ask most of this, just maybe that'll help some of you. Okay, on to part C. Part C is a really tricky question. I'm not going to be able to write much about it. It's really just one, they're asking you, do you understand what everything means here? And then they're asking you to solve a little puzzle. So the first thing that we haven't covered already is, what does this mean? Well, C union D. So we covered union here, but then what does this dash mean? That just means not. To use this as an example, A union B would be everything in these two circles, whereas not this would be everything not in there. So that'd be this 0.5. So in this question, they told you PC, they told you PD, and they just asked you, what is this? We'll answer that in a moment. They didn't tell you, they asked you what's the maximum of this, my bad. What's the maximum of this amount? They didn't tell you anything about being mutually exclusive or anything like that. In fact, these two add up to more than 1. That's a bit of information. That's impossible to happen. So if they're looking for the maximum of not C union D, what we should be looking for is the minimum of the probability of C union, they're looking for the maximum of C union D not that. We should be looking for the minimum of this. So let's draw a couple of examples, some Venn diagrams. We know this is 0.5 and we know this has a total of 0.7. And hopefully you follow my logic here, that we're looking for the minimum number of this in here. So what's the minimum number these two could add together? We can do the maximum over here. That seems easy, 0.5 and 0.7. Maybe they could add to get 1.2 if you allow that, which we shouldn't. So we could they could get to add to 1. We could do that by 0.2 in the middle, 0.3 here. They have to add to 5 and 0.5 here. That add up to 1. That's the maximum of this guy. The minimum though that these could add up to, so you could play around with some different numbers, but hopefully you see that it's to put as much in the middle as you can. That would make the overall number smaller, as much in the middle as you can. So 0 here, 0.5 in there, and 0.2 there. So this would be a total of 1. This would be a total of 0.7. And remember, this is all just for the union of C and D. So the minimum, the smallest number I can get for C union D is 0.7. So remember, they asked for not. So not this would be 0. They want the biggest possible though. Not this would be 0.3, just 1 minus. So what's the largest number you could ever get for this? 0.3. Part D, it tells us there's an event E and F. I don't need to write anything down for this. An event E and F. E is, it will be raining tomorrow, and F is, will I wear a coat? So they said explain why it would not be reasonable to assume that E and F are independent, not related to each other. Well, the answer is what I'd expect any student, pretty much any person in the world, if I explain this to them. A lot of people will be confused. You watching this could be, I don't know how to answer this question. I'm confused by it. But if I asked you to make a guess, to not worry about what anyone thought, make a guess, I would expect nearly everyone's answer is, well, if it's raining, I would wear a coat. If it's not raining, I would be less likely to wear a coat. Maybe if it's cold, I'd still wear a coat. But the fact it's raining will increase the chances of me winning a coat. Any combination of those couple of sentences I just said is the answer to part D, and that's all you need to do. If you have any follow-up questions for anything I did here, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.